Welcome! In this video, we'll explore how to use CODAP's Sampler plugin to generate data from a model. Let's start by opening the sampler. The sampler is one of many built-in plugins that extend the basic capabilities of CODAP. From the top menu, click Plugins. Then select Simulation and choose Sampler. You'll see a mixer full of objects. Think of it like a hat filled with slips of paper where each slip represents a possible outcome that CODAP can draw at random. You can add more objects with the plus button or remove them with the minus button if you've added too many. You can also switch between the spinner and mixer view, depending on how you want to visualize your random process. You will also notice the collector option. We will not be addressing this option in this video. In the dropdown, you can toggle between with replacement and without replacement while using the mixer. By default, CODAP samples with replacement, meaning each object is put back into the hat before the next draw. If your model involves more complex or compound simulations that require additional logic or involve multiple stages or choices, you can add more devices using the Add Device and Add Branch buttons. There's also a handy Hide a Device icon on each device here. Teachers might use this if they don't want students to see the underlying setup of a model, such as for tasks where students are asked to infer something about a model or population based on simulated data collected. Now, for an example. Let's think about how we could model a classic carnival example, the duck pond game. In this game, players choose rubber ducks from a pond. 20% of the ducks are winners and have win written on the underside of the duck, and the other 80% say lose. Each player pays $1 and gets to pick a duck 3 separate times. After each pick, the duck goes back into the pond and gets mixed around. To model this, let's think about a simple pond with just 10 ducks in it. I'll create 10 objects in the mixer. I'll label 2 as win to represent the 20% winning ducks, and 8 as lose to represent the 80% of ducks that won't result in a prize. We can also label this mixer as result to represent the results of each duck draw. We are going to keep the default setting of with replacement, since the ducks get returned to the pond after each draw. If I switch to the spinner view, I can see the same distribution displayed as a spinner with 2 outcomes and can see the 20% and 80% represented as 2 sectors in this spinner. Up here, you can set your sample size and the number of repetitions, that is, how many times CODAP should run your simulation. Now, let's model the game itself. I can ask myself the question, after randomly choosing 3 ducks, what are the chances of winning a prize for all 3? I can test this out by simulating to see about how many prizes will be won in this scenario. I'll start with one mixer with my 10 balls, and I'll change the number of items from the default 5 to 3, since that's how many ducks each player can pick. For starters, I'll simulate 6 players, so I'll collect 3 items representing 1 game and repeat this for 6 samples, representing the 6 players playing the game. Then I'll click Start. As CODAP runs, you'll see the balls, representing our ducks, being selected 3 times per player. After the simulation finishes, a hierarchical table appears automatically. At the top level, you'll see the overall experiment. Next to that, each sample represents 1 simulated player. And within each sample, you'll find the results of their 3 draws. On the outermost level of the table, I see that so far I have only run 1 experiment. In the next level, I see that I have taken 6 samples, and in the final level, I see the results of the 6 samples I took, 3 values from the first 3 values from the second, and so on. For example, if I click on sample 2, CODAP highlights that player's sequence of results. Now that we have our simulated data, we can graph it. I'll open a graph and then drag result to the x-axis to plot the outcomes. I can also separate my results by which sample they belong to by dragging sample to the y-axis. Now, let's make this simulation a bit more realistic. I'll collect another 44 samples and set the speed to fastest. When I click Start, the table fills quickly with results from a total of 50 simulated players. The original 6 plus these new 44. Clearly, this graph is not so helpful anymore, but I can use the Measures tab to calculate a measure that may be more helpful to me. When calculating a new measure using the Measures tab, it is important to note that the calculation will be for each sample, in this case, for a game where a student drew 3 ducks. The measure is thus created at the sample level in the hierarchy. If I want to calculate how many ducks resulted in a win in each simulated round of play, I can edit the formula and count the number of times win appears in each sample. Now let's graph this new attribute. Notice I can change this attribute to be treated as categorical and change it into a bar graph. Now we can see how many players won no prizes, how many won 1 prize, how many won 2 prizes, and how many won 3. And that's how to use CODAP's sampler to generate data from a model, in this case, simulating a carnival game.